Hello everyone, and welcome back to another Mathematics and GIS lecture video. And in this video, what I want to do is I want to talk about intersecting lines and the point at which lines intersect. If you remember in previous videos, right, we talked about perpendicular and parallel lines, and we said that any line with the same slope would never intersect, and we said as long as their slopes weren't the same, they would always intersect at some point. Well, in GIS, and we're going to go through some examples, some specific examples after this, all right, knowing where two lines intersect is an extremely common and important task. So we need to figure out two things. How do we figure out where lines intersect? And two, how do we know if that point of intersection exists inside of a line segment, that we are actually using in our GIS, right? Because up to this point, we've talked about lines as this abstract equation, right? In GIS, we're dealing with coordinates that represent the start and end point of a line. So what I want to do is I want to talk about two lines. So we have line AB, which is this purple line right here, which has the starting point 1, 3 and the ending point 4, 4. And I've gone ahead and I've done the math to figure out the equation, so we don't have to go back through that. If you don't know how I got this equation, I would recommend going back and watching the generating a equation from 2 points video. And then we have this line CD, which has the slope y equals negative x plus 6. And so I've sort of taken those and I've generalized them over here. Y equals 1/3 x plus 2/3, and y equals negative x plus 6. So what we want to do is we want to figure out, well, do these lines intersect? So the first thing you have to do is, do they have the same slope? The answer to that is no. Then that means that they're going to intersect somewhere. Now the question then becomes, where do they intersect? And to answer that question, the way we're going to do this is we're going to set these two lines equal to each other, right? We want to know at what x value are they going to have the same y value. So we're going to set these two equations equal to each other. So we're going to say 1/3 x plus 2 2/3 is going to be equal to negative x plus 6. So what I like to do is I like to group like terms together. So I'm going to add an x to this side. So that's going to be 1 1/3 x plus 2 2/3 is going to be equal to 6. Then I'm going to subtract 2 2/3 from both sides. Again, this is just basic algebraic manipulation here. So we're going to have 1 1/3 x is going to be equal to 6 minus 2/3 is going to be equal to 3 1/3, right? Because if you add 1/3 to 2/3, you get 3. Or if you add 1/3 to 2/3, you get 1. 1 plus 2 is 2. 1 plus 2 is 3. 3 plus this 3 is 6. Right? So now, in order to do the math without a calculator, I'm going to convert these to improper fractions. So 1 1/3 is going to be equal to 4/3, right? Multiply the whole number by the denominator and then add the numerator. All right, so we have 4/3 x is equal to multiply the whole number times the denominator, which is going to be 9, plus the numerator, so it's going to be 10/3 here. Right, if that was confusing, I strongly encourage you to go watch Khan Academy on how to convert fractions. Right, so now what we need to do is we need to divide both sides by the number in front of x to isolate x. When you divide by a fraction, that's the same as multiplying by its inverse. So we're going to multiply both sides by 3/4. So we'll get x is equal to 10/3 times 3/4. When you do multiplication of fractions, you don't have to worry about common denominators. You multiply the top and multiply the bottom. All right, so this is going to be 10 times 3 is going to be 30 over 3 times 4 is going to be 12. Right, and we can reduce this slightly. Right, we can divide everything through by 2 to get 15/6, We can divide that further by 3 to get let me move over a little bit so we have a little more room here. We can divide everything through by 3. Divide the top by 3, you get 5. Divide the bottom by 3, you get 2. And this is going to be equal to, if we turn this back into a mixed fraction, you divide the top through, this is going to be equal to 2.5. Right. So we know the x coordinate is going to be 2.5. So this, so let's go ahead and label this really quick. Right, this 2.5 right here, right, this is the x coordinate. Of our intersection point. Right. So this is the point on either, this is the x coordinate of either line where they're going to be equal to each other. And if we scroll back over to our thing here and we go, so here's 2, here's 3, this is roughly 2.5. If we go up, right, we're pretty much right on 2.5. So we've done our math correctly. So now that we have this, we just have to figure out, okay, well, what is the y coordinate of this point? So we know the x value, right? We know that the x value here, right? We know the x value is 2.5 because we calculated that out. What is this y value? Well, to do that, we simply plug that 2.5 back into either equation and solve for y. I'm going to use this equation because it's a lot easier to deal with. All right, so to solve for y, we do y equals negative, and then our x value is coming from down here, is 2.5 plus 6. Right, we can rearrange this equation because adding a negative number is the same as subtracting, so we can rearrange this equation to do that is equal to 6 minus 2.5. Hopefully I didn't confuse you in doing that. Right. So if we subtract away the 2, that's going to be 4. Subtract away a half, you're going to get 3. So we're going to get 3.5. Y equals 3.5. Right. So now we're going to go back here and we're just going to confirm this is 3, this is 4, and we're pretty much spot on halfway in the middle. So our math checks out there as well. So we now have an equation, or sorry, a set of coordinates, right? We have the coordinates 2.5, 3.5, right? And these coordinates correspond to, let's use gray, let's make this big. Right. These coordinates correspond to that intersection point. Okay, so now we know where, but the question is, do the line segments intersect? And to address that issue, we have to look at these coordinates in response to the line segments in question. And the way we do that is we ask ourselves, I'm going to scroll down a little bit. Hopefully we can still see everything we need to see here. So let me scroll up just a little bit. We'll use the space above a little bit. Right. So to determine whether or not these actually intersect, right? We know where the lines intersect, but now we have to say, do these line segments intersect? And you have to ask yourself 2 questions. Well, it's really four questions. Let me make that smaller so it's not so big, right? For each line, is the x coordinate in the range of x values, and is the y coordinate in the range of y values? What do I mean by this? Well, what I mean is for each line, so we have two lines, we have line AB and line CD, we have to ask ourselves, is the x-coordinate in the range of x values? So what that means is we're going to look at this 2.5 and we're going to take line AB first. And we're going to say, does 2.5 fall between the x-coordinate of the first point and the x-coordinate of the second point, right? So in this particular case, right, we're saying something like this, right? We're saying, is 1 less than 2 and handwriting got really bad. Is x greater than 2.5 less than 4, right? Check. So then we're going to do the same thing for line CD, right? So we're going to say, is 2 greater than 2.5 less than 4. Check. So now we've proven that our x-coordinate is in the range of both of the lines. And then we're going to do the same thing for the y. So we're going to say, is 3 less than 3.5 less than 4? The answer to that is yes. And then finally, we're going to say, we're going to go again, going lowest to highest. So is 2 less than 3.5 less than 4? And the answer to that is also yes. So in this case, right, we've gotten all 4 of these questions back yes. So that means we know where it intersects. We know the intersection is within the range of all of the lines. So indeed, these two lines do intersect at the point 2.5, 3.5. I know there was a lot here. I know we covered a lot of different points. We covered how do we calculate the intersection, how do we verify that it's actually within the range of the lines. If any of this was confusing, please pause the video, please go back, please rewatch the part you're confused about, and as always, please reach out. Thank you.